Hello, this is Rémi Lafage from Monera, actually from home due to COVID-19 outbreak. But anyway, I'm going to show you today how to deal with uncertainty in WhatsOpp. So as always, we are going to start with the seller analysis. So we have seen how to define an optimization problem with x and z as design variable. But today I'm going to, well, somehow step back and see how we can consider x and z as uncertain variables and see how the uncertainties propagate onto the outputs. So first I'm going to copy the analysis. And then I'm going to edit this parameterization. So we can see when we copy, f, g1 and g2 are just responses, and x and z are set to a parameter role. But I'm going to change that, and x is going to be an uncertain variable. So we can see that lower and upper bounds are taken to define a uniform law for x between 0 and 10. For z, I'm going to suppress the bounds and then change the role to uncertain variable. And then we can see that by default it has just taken the init value, 5 and 2, for the two components, and it has taken a normal law for the two components. Maybe I can edit one. I can see, you can see that I can change here the distribution. Well, I'm going to keep the normal law and maybe, well, change the sigma here just to show you the addition. Okay. Here. So here we have defined our seller analysis with uncertain variables. So we are ready to generate some code. So here I'm going just to list the analysis to see the ID of our newly created seller. So I can pull the code 256. Okay, and then here we can see that we have generated here the code. This directory, it's just a directory that contains the implementation of the, I've saved that directory before, it was not generated here. Just to implement the various disciplines, because as you may know, by default, the outputs of discipline are set to 1. So I'm going to implement the various disciplines. So just copying their implementation here. Functions, discipline 1, discipline 2. Okay. So we can check that discipline 1 is now implemented. Okay. I'm going to run the analysis just to check that everything is okay. It seems to be okay. And then I can run the DOE with the script that was generated. And I'm going to generate 100,000 points. Okay, maybe I can mention while it's computing that WhatsOpt use OpenTURNS, which is a framework to deal with uncertainties, risk, and statistics. Here we can see their website. I encourage you to check it because there is many information about uncertainty quantification. And then, well, just to mention that behind the scene, all the code generated use OpenTURNS. So we have generated the DOE. Then we can see we have our CLR DOE SQLite file. So we can upload these results. CLR, okay, like that. And then go back here on WhatsOpt and see the list of operation, and we can see we have generated a DOE with OpenTURNS, and we can see the results. So here we have the histograms showing the inputs, so we can recognize we have a uniform low for X and normal lows for Z0 and Z1. And we can see here the results, the propagation of the uncertainty on the various outputs F, G1, and G2. We have also, well, the cobweb plots, and also the scatter plots show also the distribution. So this is the first way to study the uncertainty, but we can go a bit further by generating, with the help of OpenTURNS, the polynomial KO expansion metamodel for our analysis. So I'm going to do that right now. And here we can see the quality of our surrogate model, which is pretty good, because the R-squared coefficients are really close to 1 for all the outputs, and we can see on the diagram that the prediction versus the true value are well, very good. So with that, the nice thing with the polynomial KO expansion is that it gives immediately the Sobol indices for the various outputs. So here we can see the sensitivity of the various outputs regarding the inputs. So we can see that F depends mainly on X, while G1 and G2 depends on mainly on ZO. It gives in fact the variance of the output due to the various inputs. So we have a quantification of the uncertainty for each output. So, well, we can recap now what we have done so far. We have generated a DOE using distributions for the inputs. Then we have generated a meta model using the, oh, maybe I can show again the distributions. Then we have generated a meta model using polynomial KO expansion method, and then we end up with the Sobol indices that gives a quantification of the influence of the inputs on the outputs. Okay, that's all. Thank you for watching. Bye-bye.